Alright, welcome back. This is the next installment, I guess, of Riemann sums. This is the second to last notes for 4.3. We have another one afterwards. I don't know what it is, properties or something. I don't know. I'll get to it in the next video. I'm not worried about it right now. But last one we talked about left-hand, right-hand sums of Riemann's. In this one we're going to be talking about midpoint trapezoidal and how they can be somewhat similar. They can be somewhat different. So we got to make sure we understand that. And so remember, the left-hand Riemann sum is just from the left-hand side on. The right-hand Riemann sum is from the right-hand side on that way. So the midpoint is going to use the midpoint of each rectangle. So I'm going to have specific values. My interval is going to be however many rectangles I want. And in between those rectangles, I'm going to have that is going to be that height there. The midpoint sum, both over and underestimate for each rectangle. So you can see that if I make a rectangle, I'm going to have some underestimate like right here, but I'm going to have some overestimate right there. This is over, this is definitely under, this is over, this is definitely under, right? And so it is closer than left hand, right hand, because the over and under kind of balance out a little bit. But it is still not exact, right? So this is still going to be some sort of approximate value. We're not quite exact yet. So I want to use the midpoint sum to find the area underneath a curve of x squared plus 1 on 0 to 2 with 4 even intervals. So what does this graph look like? Okay, this graph is going to start at positive 1, so this is going to be at 1. If I plugged in 2, I get 5, right? So we'll say this is 1, we'll say this is 2, and then 5, so we'll say 1, 2, 3, 4, 5, and then it's going to be up there, and we're going to go like that. Okay, so it's an increasing function, and now I want to find our rectangles and stuff like that. So I want 4 even subintervals, so from 0 to 2, that means I'm going every half. Okay, so every half is going to be my interval. So I'm going to have 1, 2, 3, 4 rectangles. But remember, that's the amount of rectangles, but because I'm dealing with midpoint, I want in between those rectangles, I want the halfway point. So in between 0 and a half, this is going to be a quarter. So I'm going to go up, and I'm going to make my rectangle for a quarter. Oh my gosh, that is awful. I can't draw this thing straight, man. I don't know what's going on here. Let me try to figure something out here. I'm just gonna, I guess, do this. Okay, so I'm gonna. Oh, that's no bueno tambien. Delete. Okay, so I'm gonna go from my midpoint, which is a quarter. I'm gonna go up to the line, and I'm gonna basically draw that there. And then my rectangle is going to kind of use that height as that rectangle, right? And so technically, I guess I didn't need to draw that middle one. Shoot. There we go. So there's my height right there. Hopefully we can see that. So I'm going to draw my... Oh my gosh. Oh my gosh. This is going to be another terrible video, guys. I can't even do it right now. I am beyond words. So this point is going to be midway. There we go. There is our first rectangle. Yay! Halfway between that is 3/4. So 3/4 is up here. So I'm going to make my rectangle from there down. Halfway between 1 and 1 1/2 is 1 1/4, which is there. So I'm going to go up, follow that. Okay. So there is that one. Oh my gosh, that one's bad. Yep, that one was muy mal. Okay, and then halfway between 1 1/2 and 2 is 1 3/4, so I'm going to go up there. And then you can see, I mean, my drawing is terrible, but you can see that you have some over and under a little bit. I'm just a terrible drawer, so I'm very sorry about that. That's a terrible graph. If I was using like pen and paper, it'd be a little easier. Like, you should be okay. And so how do I find the area of this? So the area is approximated, okay? The width of every rectangle is still going to be the same. That's going to be a half, right? So I'm still going to get a half, but what's going to happen is instead of finding like f of 1, f of 2, f of 1.5 or whatever, I'm using that midpoint value where I drew my rectangle from. So I'm going to use a quarter. So I'm going to find f of a quarter. I'm going to add it to f of 3/4. I'm going to add that to f of 1 1/4, so 5/4. And I'm going to add that to f of, I believe it's 7/4 if I did my math right. All right, and I'm going to use my calculator to find that. You can easily plug that in and chug it. Like a quarter squared is 1/16. 1/16 is plus 1 is 17/16. Okay, and so on, plus all of this. And then you multiply by a half. And then you're going to get somewhere in the neighborhood of 2.3125. Okay, again, 3 decimal places or more, but no less. All right. I'm sorry, this is a train wreck. Okay, next one. This is the same, well, not the same one, but very similar to what we had on the last one. But because I want 3 equal partitions, okay, I'm going to say, I'm going to probably go from here to here, from here to here, and from here to here. So every partition is worth 2, all right? And then I'm going to take the midpoint of each partition. So the area is approximated as the width of each rectangle is 2 times, and then the midpoint. So f of 2 plus f of 4 plus f of 6. Okay, you can get that value. So it's really 5 plus 8 plus 19, which is 27. 5 is 32. 32 times 2 is 64, and that's your area there. Okay, great. All right, next one is called a trapezoidal sum. Trapezoidal sums are one of the more accurate areas. Okay, it's more accurate than left and more accurate than right. But you can see that there are some places where it's not very accurate. And if you actually look down here, it's not very accurate. Okay, so when f of a figure is equal to f of b, this is, you don't have to write down, it's not that big of a deal. When f of a is equal to f of b, and the graph is continuous, so we talk about Rawls theorem, right? So this is kind of Rawls theorem. That's basically what you can think about this. So this is like f of a is equal to f of b. It's not, they're not equal, but it's pretty close. But it's continuous, so you know the function has to go up and come down, or come down and go up. And so you're going to have a big chunk that's either not accounted for, so from here to here, this graph will not even be accounted for right there, or from here to here, this is going to be filled in when it really shouldn't. Okay, so got to think about that. But anyway, that's not that big of a deal. It's not very rare that happens. So this is what it looks like. The trapezoid, I'm making a trapezoid. So from the beginning of each rectangle to the end of each rectangle, I'm just drawing a line, and then that's how I get my rectangle. So the height is right here, right? And then this is base 1, this is base 2, and then I multiply by the height and divide by 2. That's, again, the formula for area of a rectangle. Oh, I'm sorry, area of a trapezoid. Whew. Man, I'm telling you, my geometry figures are not on fleek today. Use a trapezoidal sum to approximate the area underneath a curve of x squared plus 1. So now I got to draw this stupid thing again. I'm sorry. So let's see. 1, 2, 3, 4, 5. I'm going to go out a little bit more. 1, 2. So there's 0, 1, and then up here, and then so I go like that. Okay, and I want a trapezoid, so with 4 equal intervals. So I'm going to go. It's not going to be a half, and it's going to be a 1 1/2. And so then I want to find the area of each rectangle. So from 0 to 1, right? This is right there. I'm basically drawing a line straight across, and then a line straight down. So from here it goes up. I'm drawing a line straight across, and then a line straight down, and then there's going to be there, and then this is going to go up as well, and then there's going to be a line going across. Okay, again, my drawing is terrible, so I'm sorry, but you get the gist of it. So the area is going to approximate it as a couple of different things here. So because the distance between each rectangle is a half, or the height of each rectangle is a half, okay, then I'm going to multiply now that by the area of each box. Okay, of each, I'm sorry. the 1/2 is the height of each rectangle. Okay, so remember my formula is 1/2 times base 1 plus base 2 times the height. But in this case, the height is a half. So this half, I'm actually pulling out, okay, and I'm finding base 1 plus base 2 and divided it by 2. I'm doing this for each of the pieces on the inside. Okay, that's where I get those things from. I'm not just making them up. Sometimes it probably seems that way. And so base 1 plus base 2. So base 1 we know is going to be f of 0 plus f of a half. And I'm going to divide that by 2. Okay, I'm going to then add that to f of a half plus f of 1. Divide that by 2. Plus f of 1 plus f of 1.5. I'm sorry, 1.5. Divide that by 2. Plus f of 1.5 plus f of 2, and all of that divide by 2 there. Okay, and so when you do the math, f of 0, you can do the math, right? So f of 0 is just going to be 0 plus 1 is 1. So this is going to be 1/2 times 1 plus 1/2 is 1/4. 1/4 plus that is 5/4. All of that's over 2 plus, and then you can do the rest of this. I'm not going to do that. You can use your calculator. I mean, that's not a big deal. Okay, and then you're going to get your answer to be about 4.75. All right, so this was 4.75. The midpoint was about 2.3125. So it's the same function, but basically half as little. So I kind of do wonder what the actual answer is. I'm going to just do this from now. Hold on real quick. I'm just going to do this real quick. X squared plus 1 dx, right? So I get x to the 3 over 3 plus x from 0 to 2. So I'm sorry, I'm doing the math real quick. This is 8 over 3 plus 2. And that's just 0 minus 0 minus 0. And so 8 over 3 is 2.6 repeated plus 2. So that's about 4.6 repeated. So my answer is 4.75. So that's really, 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 really close. Okay, that midpoint formula was not even close. All right, trapezoid in this case was a lot more accurate. Okay, let's do one more example here and then call it a video. All right, this is the same one from the last video that I made. This is now just the same values are there, I believe. I believe. But it's now a of t. So the acceleration of a particle is given in the function below. If the initial velocity of the particle is right here, find the velocity of the particle at time equals 8. Okay? So what does that mean? That means that I want to find the v of 8, all right? So right here at t is equal to 8, so right there, okay? I have to integrate, okay? Remember we did initial conditions in 4.1. We had to integrate the table. We had to find the area underneath a curve. That's what integration is. But in this case, I can't integrate a function because there's no function, right? So what I have to do is I have to take these, all right, and we're going to use the trapezoidal rule. I don't know if it necessarily matters what you use, as long as usually it'll tell you use trapezoid, use a left-hand Riemann sum or a right-hand Riemann sum. In this case, we're going to use trapezoid because we're in the trapezoid piece, but it's not that big of a deal. Usually it will tell you what you're using, okay? Especially if it's a table. It will tell you what to do. All right, so let's use a trapezoidal rule. In this case, I'm going to say, okay, from here to here, from here to here, from here to here, and from here to here. So I'm going to have 4 different rectangles. And I'm going to say that v of 8 is approximated as a of 0 plus a of 2 divide by 2. So this is your base 1 plus base 2 divide by 2. That's standard in your trapezoidal formula for area, times by 2, because that's how wide the box is or how tall the box is, right? Plus f of, I'm sorry, not f, a, plus a of 2 plus a of 5 over 2, that's again the standard, times, now that's by 3, right, because that's how tall that box is, plus a of 5 plus a of 7 over 2, times 2 plus, and then a of 7 plus a of 8 over 2 times 1, right? Because that's how tall that box is there. And then I just plug and chug basically. So this is going to be a of 0 is 0 plus 4 over 2 times 2 plus a of 2, which is 4 plus 13 over 2 times 3 plus 13 plus 21 over 2 times 2 plus 21 plus 23 over 2 times 1. So once you do that, you figure that value out. Oh, I'm sorry, I forgot to do something. Remember, we're finding the initial condition, so this is really a plus c at the end. So there's some value of c, okay, at the end. All right, so we know that this is going to be equal to about 85.5. Sorry, 85.5 plus some constant, all right, which is equal to v of 8, because that's what I want to find. I want to find v of 8, right, velocity at 8. And so we know that the initial condition is 3, so this c is actually going to be 3. So v of 8 is going to be equal to 85.5 plus 3, which is about 88.5. Okay? And we don't have any units, right? So it doesn't really, the units don't matter on this problem, but maybe meters per second because it's velocity. But there you go. That is how you do trapezoid and midpoint. So on to the next one, which is the last section of 4.3. All right, so deuces. See you later.